Hi everyone, my name is Thomas Kim. Today is April 5th, 2024. It is 9:11 a.m. From my YouTube channel, scroll down, you can find OpenGL and CUDA. Click this playlist. From this playlist, select 009 CUDA. In our previous episode, we defined concepts for complex numbers. Scroll down, show more, download current video source code, show in folder, unzip it, rename 10 operators, copy the folder path, paste it in your working directory, open up Visual Studio Code, OpenGL CUDA, from folder 10 operators, double-click complex.cu, from CEX folder, double-click cexmath.hpp, Ctrl-V. I will arrange side by side. In my previous episodes, we created class complex. If you don't skip my videos listed in this playlist, you can implement complex number classes whose data elements are functions. I will modify this part. Template CPT number C. Type. Then, using this type, we will use typecast. Also, here, type. We need typecast here, also typecast here. Now, copy this, scroll down. We will update this part. This is type. Once again, overwrite it here. This should be type. This should be type. I will give line break here. SED, common, type T, type, float. Copy this, then paste. Copy this, line break, paste it here. We modified class template argument deduction guide. With this, Ctrl-N, test complex number 1. In this function, scroll down. Now we can use integral type. Open up your command prompt, cd 010 operators, nvcc complex.cu on.exe sed c++20 -x compiler wd 4819 -expt relaxed context for extended lambda cls n. It should build successfully. I will make one more changes. Here, R-type, I-type, R-type, I-type. Copy this, paste it here, R-type, I-type, then R-type, I-type, float. Copy this, overwrite. With this, it can be double. We build again. CLS N. It should build successfully. Now we will add one more concept. We created this code in our previous episode. Copy, paste. It can be STD complex. Copy, paste it here. It should be STD complex type. Delete this. Scroll down. In this part, copy this, copy, paste, STD complex C. It should be STD complex. Now scroll down, copy this, paste. I will change the concept name. Binary ALG type complex C. Here STD complex C type. I missed closing angle bracket. With this, we build again. CLS N. Now we define accessors from class complex element type. Here device or real constant no except return static cast STD complex ELE type constant L value reference. This is cast, this real. Copy, paste. Now imaginary part. It should be imag. This is called accessor getter. This is accessor getter. Now copy, paste. This is accessor setter. Return type should be void. We have to remove constant. ELE type B, remove return, remove constant. Here B, this is setter. Return type is void. ELE type B, remove constant, remove return, also remove constant. Then pass B. We will build once again. CLS N. It should build successfully. Now scroll down. Class complex real type, imaginary type. In this case, this is specialization for complex numbers whose data members are functions. Scroll down. Here, device, constant, or L value reference, real, constant, no except. Return this M real. Copy, paste. Now image M image. With this, we build once again. CLS N. Now here once again underscore device to underscore device or real template CPT floating point C ARG types requires size of ARG types. It should be parameter count. ARG types ARGs const no except return CM evaluate this M real ARGs. I haven't explained evaluate function yet. In the near future, I will elaborate on evaluate function. In case of parameter count, we defined here. I explained how to use argument count in my previous episode. Now scroll down, copy this, paste. It now should be image. It should be M image. I will create one more template, CPT floating point type. Requires 2 parameter count. Device auto real SED complex type. Const L value reference C const no except return CM evaluate this M real C real C image copy paste. Now it can be image for imaginary part. It should be M image. With this we build again. Sorry, 507. I will use SED floating point. Copy, paste. We will rebuild CLS and it should build successfully. Now we define binary addition and subtraction. Here, namespace operators. End of namespace operators. Template binary ARG type complex C A type copy paste B type requires at least one complex C A type B type 2 underscore device auto operator plus A type forwarding reference A B type B no except if context for non-complex C A type else if context for I would copy this part paste it here B type else if A is not complex number then return CEM complex A plus B. Please understand, we convert A to complex, then we call this operator recursively. This is recursion. Copy this, paste it here. Now A plus B. We call this function recursively. This is operator function calling itself recursively. Now return CM complex A real plus B real A image plus B image semicolon copy paste. Now this is subtraction, so it should be subtraction. It should be subtraction. It should be subtraction. Subtraction. We build once again. I made typo here. It should be return. Also return. We rebuild. Okay. It built successfully. Now in this code once again. Here auto z c1 plus c2 plus a plus 5. Then ct a out. We are displaying this z like this. Z real, z real, a z image, z image, a. And then I will disable this part. Also disable this part. With this, we rebuild CLS and it works successfully. We can try subtraction. For example, subtraction should also work. CLS and everything works perfectly. In my next episode, we will implement complex multiplication and division.